Hello and welcome to our second lesson in this sequence and series unit. So today we're going to learn our first formula of this unit. So I'm just going to go through a little bit of theory. Like I said, this formula sheet will be handy. Almost everything we do are just finding the formulas from the formula sheet. Even if we were still in class, you wouldn't have to memorize these. You would have been given this formula sheet to use on your test and on your exam. But again, I just want to show you where this formula comes from, so we just don't say, here's a formula, memorize it, trust us. Just want to show you there is a reason. We don't just magically make these formulas up. They do come from someplace. So based on what we know about sequences that we learned last class, I'm going to look at the AP. Remember, AP is the same thing as arithmetic progression, which is an arithmetic sequence. So there's a pattern. You keep adding the same number to each term. So I'm giving you the pattern 1, 6, 11, 16, dot, dot, dot. Remember, those 3 dots mean that the pattern continues. So we look, that definitely is an arithmetic sequence or progression. When we analyze it, our first value, T1, is 1, and the D value is 5. We keep adding 5 to each term. Okay, that should make sense based on last class lesson. So I just want to show how we go from that example to the formula that we'll be using off of our formula sheet today. So just bear with me. Let's try and write it a different way. So the pattern is 1, 6, 11, 16. Let's see if we can rewrite that same pattern but a different way. So we start with the first term. 1 was just 1. Now the second term, how did we get 6? All we did is we took the first term and we added 5 to it. 1 plus 5 is 6. Well, how did we get the second term? We took the first term and we added 2 5s to it. 2 times 5 is 10, 10 plus 1 is 11. How did we get the third term? You start with your first term and now we're adding 3 5s to it, and so on. So that's the pattern. That's how we can just rewrite each term. 6 is 1 plus 5, 11 is 1 plus 2 5s, and 16 is 1 plus 3 5s, and so on. Hopefully that's okay. Now we're going to switch from numbers to letters because it's math. We like to use letters in our formulas. Let's rewrite that using our symbols of T1 and D. So our first term is just 1, which is just T1. Our second term is you take your first term, T1, and you add D to it. You take your first term and add your D value to it. This term, you start with your T1 and you add 2 D values to it. This term, you start with T1 and you add 3 D values. So I think you get the pattern. Now here's the fun part. The pattern continues all the way to the end. How would we write the last term? So we know that we always take our first term, but how many D's are we adding to the previous term? So for the first term, we had no D's. For the second term, we had 1 D. For the third term, we had 2 D's. For the fourth term, we had 3 D's. I think we see the pattern. So how many D values are you adding to your first term? It's always 1 less than your term. Okay, hopefully that wasn't that bad. Like I said, you don't have to prove things. In the calculus course right now, they have their midterm in a couple weeks' time, and they do have to know proofs and theorems. So that's what's in store if you go on further into calculus. But for high school, we give you the formulas, but like I said, you should know where they come from. So from now on, we won't have to go through that again. Now we can just go to your salmon colored sheet and use the formula. So you should see that after our quadratic formula, law of sines, law of cosines, we now have our first formula, and it should look like this. Tn equals T1 plus n minus 1D. And I showed you in that last screen where that came from. We call that the general term for an arithmetic sequence. So using this formula, we can solve for the first term, the D value, or the number terms, or for any term. So we're just going to do 3 examples together. I'll just show you different ways we can use this formula. Now, the fun part about this unit is you technically can solve all of these without a formula sheet, right? So I'll show you. Determine the 25th term if the pattern is 2, 5, 8, dot, dot, dot. Technically, you don't need a formula sheet. You could expand the pattern, figure it out, and then figure out what's the 25th term. We know that as math teachers. So that's why on your hands-in that I'm giving to you, it'll always say the word solve algebraically. So we know that you can do that, but the point of this unit and the curriculum guide is they do want you to use these formulas to solve them. So if you're just going to expand and solve that, we cannot give you full marks. So that's why I'm putting the word solve algebraically on your hands-in. If you were writing the exam, it would have said write algebraically at the end. So they do want you to be using these formulas to solve them, not just expanding and looking at the pattern. Okay, so the first thing we should do is figure out what each term is. Do we know what T1 is? Yeah, the first term is 2. That was given in the question. Do we know what n is? Yes, n is the term we're talking about. So we're looking for the 25th term, so n is 25. Do we know the d value? Well, no, but we can figure that out. What are we adding to each number? 3. 2 plus 3 is 5. 5 plus 3 is 8. Now, do we know what Tn is? No. Students have some confusion about the difference between n and Tn. N tells you which term we're looking at. Tn is the value of that term. So that will take some practice of understanding the difference between n and Tn. So we use our formula off of the formula sheet. We don't need to memorize it. So we're using this formula today. Tn equals T1 plus n minus 1, or n minus 1d. We know n is 25. So we're looking for the 25th term, but we don't know what the 25th term is. So n is different than Tn. We know that our T1 is 2. N minus 1, well, 25 minus 1 is 24. I skipped one step. I think we can figure that out. N minus 1 is 24, and we know the d value is 3. This is pretty straightforward. We're just doing order of operations. So we do 24 times 3, which is 72. 72, I said it right and I wrote it backwards. 72, 72, don't you miss this fun part, and 74. So the 25th term is 74. So do you see the difference? N is 25, that's the position of the term, but the value of T25 is 74. And there you go, that's the formula that we'll use pretty much most of this unit. That's the pretty go-to formula for most questions in this unit. Let's try a couple more examples just to show different ways that we can use the same formula. So on the next slide, now we're asking for how many terms, and I put in that word algebraically because we know that you could just expand the pattern and count. But like I said, in the curriculum guide, the province of Manitoba does want you to be using these formulas from the formula sheet. So our arithmetic sequence is 3, 5, 7, 9, ... The pattern continues 41. So looking at this, we know that our first value, T1, is 3. What's n? We don't know. That's what we're solving for. So this time we know Tn. We know the last term is 41, but we don't know the n value. We don't know how many terms there are. So hopefully see the difference between example 1 and 2 to understand the difference between n and Tn. The d value, we have to figure it out. Oh, this is an easy one. That's 2. We are just adding 2 to each term. Okay, so I highly recommend just writing it out to see what you have, what you're solving for, and then as the students like to say, what plug and chug, we just stick it in. So this is different. This whole thing is 41. This is not T41. We're not solving for the 41st term. We know that the last term is 41. We just don't know what position that term is. We know that T1 is 3. We don't know what n is, and we know that d is 2. And this is easy. This is back to grade 9 math with just rearranging and solving for our n value. So there's a couple ways you could do that. So I'm going to subtract the 3 out first. So 41 minus 3 is 38. You could distribute the 2 collect-like terms and then rearrange and solve. You could, but I'm going to divide the 2 out now. Like I said, it just doesn't matter. It's all going to lead to the same answer at the end. So 38 divided by 2 is 19. Now that gives us n minus 1. So now we add 1 to each side. Whoops, I don't know why I did it like that. So n is 20. So that means there are 20 terms. So I do realize if you just wrote it out and expanded the pattern, you could have counted and got that to 20. But like I said, on the hand and we're doing, you do have to do algebraically to get full marks, because that's the way the curriculum guide wants us to do it, is to show that we know how to use and understand these formulas. Okay, one last example. Oh, here's a fun one, you can tell already. So determine the common difference, D, T1, the first term, and the general term for the AP. AP is the arithmetic progression, same thing as the arithmetic sequence. Now, all you're given is that the 8th term is 33 and the 14th term is 57. Oh, okay, that's a fun one. Where do we start with a question like that? Well, we know that today's lesson, we're always using this formula from our formula sheet. Tn equals T1 plus n minus 1d. So I've split it apart because we're going to get 2 different formulas. So from this one, we know that the 8th term is 33. So I know that the 8th term is 33. I don't know what the first term is. Now my n value here is 8, right? If that's the 8th term, that's 8. So maybe I'll fill it in and I don't know what the D value is. Because they told us T8 is 33, so for the 8th position, that is 33. I can clean it up a little bit. 8 minus 1 is 7, and that's as low as I can go. Okay, that didn't really get me anywhere. I'm trying to solve for D1, I'm trying to solve for D, and I know neither of them. Okay, so let's just pause a bit. We'll come back to it, and let's go to this side of the screen. So here I know that when the n value is 14, Tn is 57. I still don't know my first value. I know that n was 14. Again, we can clean it up a little bit. Okay, well, I'm nowhere. I don't know T1, I don't know D, and I don't know the general term. So, what's going on here? Well, when I go to the next slide, this now becomes a grade 10 math question. Remember when we did solving systems, 2x2 systems, 2 equations and 2 unknowns? It's not like our units this year with systems. Remember, our systems were linear, quadratic, quadratic, quadratic. These are both linear, so this is exactly grade 10 math. So you can solve by graphing, substitution, or elimination. This is a really easy one to do by elimination. If I just subtract these 2 equations, I should get some nice numbers that I can work with. 57 minus 33 is 24. T1 minus T1, they cancel each other out. And 13 minus 7 is 6D. Now we can solve D is 4. Okay, now we're getting somewhere. That was one of the things we were asked to solve. So we did all that work just to solve for the D value. But we're not done. Remember, they still want us to solve for T1 and get the general formula. Okay, but now that we have one value, it gets a little bit easier. So now, to solve for T1, you just choose one of these 2 formulas. It doesn't matter which one, whichever one you think is the easiest. I went with the one with the smaller numbers because I thought that was easier, but you can use either one. So, we don't know what T1 is, but we know that our D value is now 4. So this is really easy. 7 times 4 is 28, so to get our T1 value, do 33 minus 28. So our T1, well, the pendant work is 5. I don't know if you can read that, that's 5. Okay, so we're almost done. We solved for the D value like we were asked. We solved for the T1 value like we were asked. We have one final thing to solve for, and that's the general term Tn. Okay, so this is what we did last class when we got the explicit formula. Once you solve for T1 and D, those values never change. So those will be the same for every term in the sequence. So the first term is always 5. The n value changes, but the D doesn't. So this is just back to doing explicit formulas like we did last class. So we keep the left-hand side as Tn. Again, now we do have to distribute the 4 through. 4n minus 4. And then 5 minus 4 is 1. So that is our explicit formula. So the formula for any term to get that, Tn is equal to 1 plus 4n. Your textbook might write it a different order. They might put the n first, but that's exactly the same thing, same answer. Okay, there you go. So like I said, this formula is given to you on your formula sheet. You're always solving for one of the 4 variables that in there, so it shouldn't be that hard. So good luck with today's assignment and have fun using the general term formula today.